elements. Welcome to Unit B review podcast again. I forgot to include periodic trends, chapter 8 in it, so I'm going to put it as second part to Unit B's podcast. So talking about periodic trends. In periodic trends, in addressing periodic trends, you must use keywords, and the keywords are nuclear charge, which talks about Z, or the number of protons in the nucleus, shielding electrons, which are the electrons between the nucleus and outermost electrons, and effective nuclear charge, which is kind of the net of the first two factors, because nuclear charge tends to pull the electron cloud closer, making size smaller, but shielding electrons tend to make the size bigger by coming in between the outermost electrons and the protons, attracting them. So effective nuclear charge, an increase in effective nuclear charge will mean a decrease in size. And the periodic trends that we study, there are 4 of those: ionization energy, size, electron affinity, and electronegativity. So these 3 trends follow the same pattern, and size follows a different pattern, and this is opposite of everything else. So the size across a period, size decreases, and down a group, size increases. And the reason for that is, as you go across a period, there's a greater effective nuclear charge, because nuclear charge is increasing, but shielding electrons remain the same, because electrons are filling within the same energy level. Due to increase in effective nuclear charge, the size of atoms decrease across a period. Down a group, because you're adding energy levels, size is increasing. Also, with addition of energy levels, you are increasing shielding electrons. So even though nuclear charge is increasing, due to the shielding electrons increase, that factor doesn't count. But due to addition of additional energy levels, the size of atom becomes larger. And because size decreases, ionization energy increases, electron affinity across the period increases, electronegativity increases. Now, ionization energy is amount of energy required to remove an electron from an atom in its gaseous state. And remember, first ionization energy is always larger than the second ionization energy, because I said it other way around. Second ionization energy is always larger than first ionization energy, because after you've removed one electron in first ionization energy, the effective nuclear charge increases. Now to pull off the second electron, it takes more energy. And other thing that I want to talk here is the exceptions in the trends. So if you're talking ionization energy, then the amount of energy, ideally ionization energy should increase across a period. It does mostly, except when you hit group 13. Group 13 has slightly lower ionization energy, because now you're removing the electron from the p sublevel rather than s sublevel, and p being farther from nucleus requires lesser energy to remove an electron. Similarly, for group 16, which is oxygen group, to remove that electron takes lesser energy, so ionization energy is lower, because now you're removing a paired electron. Okay, so there is electron-electron repulsion, so it takes lesser energy to remove it. Now in electron affinity, the trends are the group 2 electron affinity is slightly lesser. Why? Because if you're adding the second electron, then it is pairing up. Due to electron-electron repulsion, the electron affinity will be lesser. Similarly, if you're adding the fourth electron, so in nitrogen group 15. So this will be group 1. Okay, trend wise. So group 15, as you're adding the 4th electron, due to electron repulsion, electron affinity will be lesser. So remember these trends, go over the PowerPoint for exceptions as well. And with that, we conclude Unit B podcast.